Hello everyone, my name is Michael Covington and I make videos about a great variety of subjects. This one is about the repair of an intercom that my daughter found in her vintage 1960 house. Now, this is not the finest videography I've ever done. It's going to be made of several recordings spliced and edited from different occasions with different cameras. First, I'm going to take you through the circuit diagram of the intercom, which I received before I received the intercom itself. And then after extensive discussion of the circuitry, I'm going to show you the highlights of the repair itself and the ways in which I discovered that the intercom wasn't exactly what the diagram showed, but we did get it working. So let's get started. What I want to talk about now is this intercom, which my daughter and son-in-law found in their house, vintage 1960 in Kentucky. It's installed there. It doesn't work, but we're going to get it working and make it safe to use long term. It's an Intercom model D-2 from Music and Sound Incorporated, often known as M&S in their later products. I think they may still be in business as M&S Systems. And this is what its face looks like. It obviously has an AM radio built into it. That's the tuning dial. It has a speaker that you both listen to and can talk into. It has switches, off and on, off when up, on when down, for the main unit, that is this speaker, the door speaker, which I will talk about in a minute, and up to 5 speakers in bedrooms or other parts of the house. When they're on, they hear the sound that's being sent through the system, whether it's from the radio or from people talking. And when they're off, they don't get sound sent to them. But the ones in the bedrooms can always still talk by using their talk switch. I'll get to that in a moment. And then all the ones that are on will hear them. So down here we have several things. We have a power outlet. Why is there a power outlet in the front of the intercom? It doesn't look terribly useful. It's actually not a good place to plug in heavy appliances. They say it's limited to 700 watts. It would be fine for a cell phone charger or some other low power thing they didn't have back in 1960. In fact, it may have been for a record player. I'll get back to that. But the other reason there's an outlet here is that another model of this intercom had a clock in it, and the clock could be used to switch on the intercom, the radio, and whatever is plugged in here at a particular time that you set on the clock. Okay, here's the talk listen switch. Normally you keep it set to listen, and the main speaker hears whatever sound is being sent out across the system, unless the main speaker is turned off, which it could be. When you turn this over to talk, then you can talk into the main speaker, and the rest of the system will hear you if their speakers are turned on. There's a volume control for the intercom and a volume control for the radio because they may be different loudnesses. You might want the radio a good bit softer than the messages talking. And this is the 4-way switch we're going to keep coming back to. You can have just radio, which makes this into a radio that plays in different rooms of the house. You can have intercom and radio, which is just like that, but people can talk also. You have intercom, which is like that without the radio. People can talk to each other. And there's phono, which would be for playing the sound from a record player plugged into a jack in the back of this intercom. Now, that is a feature I do not recommend using. Any audio equipment that's designed to have other audio equipment plugged into it should have a power transformer isolating it from the AC line, and this one doesn't. But it might be a good place to add Bluetooth if we add a Bluetooth receiver as a modification to this intercom so that a 1960 audio system can get the sound from a mid-21st century cell phone or what have you. This is one of the units in the bedrooms. So each bedroom unit, or station as it's called, has a switch, listen or talk. When it's on listen, it hears the sound that's being sent out throughout the intercom, whatever that might be. And when it's on talk, you speak into there and the rest of the system hears you. There's a volume control that controls how loud it is. This should normally be kept turned all the way up. If you turn it all the way down, you can neither talk nor hear, and you do have privacy. Your intercom unit doesn't send or receive any sound when its volume is turned all the way down. Let's look at the circuit now. We found a schematic diagram in the intercom, and I took a photograph that my daughter had taken of it, fixed it up a bit with Photoshop, and added some more information. I know you can't read it at this magnification, so I'm going to magnify it a bit. The overall circuit is very similar to a standard classic American 5-tube AC/DC AM radio. This would actually run on 120 volts DC if you happened to install it on a place that had DC power, as a few places still did back then. And it has 5 tubes. What look like 2 tubes here are actually 2 in one glass envelope, and then we save a tube by having a diode detector to make up for the extra part added to accommodate it also being an intercom and needing to be able to take the weak signal from speakers used as microphones. Let's look over the whole circuit a little more closely. I won't go over all the details because this is a very conventional standard circuit. This is the AM radio section. The incoming AM signal from the antenna, I presume it has an antenna that might be a loose wire that sticks out of its metal box into the unshielded wall, gets taken in here, down converted to 455 kilohertz, run through a tuned transformer, another tuned transformer with a tube in between to amplify them. And so with these 2 tuned transformers at a fixed frequency, we get very good selectivity and sensitivity from a simple radio. There's no tube to demodulate the AM signal. Instead, there's a Sylvania 1N34 germanium crystal diode, which was a very modern thing in 1960. So this is the radio part, and there's not much that is important about it, except that there is a way to disable the radio. The radio will only work when this wire, which is the cathode return of the converter tube, when this wire is connected to circuit ground, which is this wire. So the big 4-way switch connects the 2 of them together when it's in its first 2 positions, radio and radio plus intercom. Otherwise it doesn't, and the converter tube doesn't get power, and the radio is off. That's a rather interesting bit of clever circuit design. They don't just cut off the audio signal coming from the radio, they actually disable the radio. By the way, one of the rules of the road in this diagram is wires that cross each other aren't connected unless either they have a dot or they dead end to each other, like there. I would have put dots there and there also. These 2 wires, this one and this one, don't connect. They're shown crossing without a dot. When you look at a schematic diagram, it's always a good idea to find out early on what they have done about that, because different diagram drawers do things differently. So the audio section, then, we have a lot of switching here to determine which audio signal from the radio or from the intercom gets sent to the rest of the system. The 4-way switch has 3 layers here to do various things with that. There is a phono input here where you could put in an audio signal and have it go to the system when you have the switch in the phono position. As I said, I don't recommend using that. This is the sound coming in, the red wire from the speakers. Sound coming in from the speakers or stations gets amplified and can be sent back out to the other speakers or stations. This is the transformer through which the audio signal goes out, ready to drive speakers. And this is the power supply, and this is a good part to look at next because I've used yellow to mark some electrical safety concerns. First of all, this model doesn't have the clock motor or the clock switch, so we can ignore this and this. Here's where the electric power comes in. The biggest safety issue here is that when you look at the AC plug where power comes in, one side of it goes to circuit ground, which is connected to many different points in the circuit and is poorly isolated from chassis ground, and I will get back to that. We will use a non-contact voltage detector to make sure the neutral side of the power line, which is the one that's grounded at the service entrance for power, goes to the chassis ground. Now, we don't have the clock motor or the clock switch contacts. We do have an outlet on the front of the intercom, and we will need to make sure we know which one is live and which is neutral. Here we have something that almost made me screech. We have a capacitor connected across the AC power line. Here's incoming AC through a switch, here's incoming AC. If that capacitor were to short circuit, it would burn something up. So, while that was usual in 1960, they weren't nearly as fastidious about these things, but I'm going to replace this with a line-rated capacitor, one that is designed to be safe to connect across the AC power line because it will not short circuit, or if it does, it will instantly disconnect inside itself by burning through a small conductor that's hidden deep inside its plastic case and won't hurt anything else. Okay, here's a bit of what happens to the AC power after it comes in. These upside down V-shaped things are the filaments or heaters in the tubes, the thing that makes the tube light up. This, which is drawn strangely with no circle around it, is a power on lamp, a bulb, that lights up when power is on. And it's strange for it to be relying on one of the tube filaments to be regulating its voltage, but at least the important thing is if any tube filament burns out, none of them get power, and this lamp doesn't get power. So if any tube burns out, all the tubes will go dark, and we have to test them one after another. This 35W4 turns the incoming AC into pulsating DC. Then these electrolytic capacitors turn it into smooth DC, smooth direct current. And if they date from 1960, they are almost certainly no good now, even if we do get a little bit of life out of them. So I'm going to replace them all, possibly with larger capacitances in all but the first one. They're currently 50, 80, and 20. I think if I make them 47, 47, and 47, it will be fine, or maybe 47, 100, and 47. We don't make large increases because the inrush current charging the first capacitor for the first time would be larger if we put a larger capacitor there. All right, there was one more electrical safety concern back here on the left side. Remember I told you this triangle signifies circuit ground, which is a reference point for a lot of signals and voltages in the circuit, including the black wire that goes to each of the stations. Chassis ground is the metal case of the intercom, and it needs to be grounded for shielding so the radio will work well. So there is a connection between circuit ground and chassis ground that's a 0.05 microfarad capacitor. And that could have AC line voltage across it if things went wrong. So I'm going to replace it with a line rated capacitor. All right, let's talk about how all the connections are made to the stations. I have no idea what they meant by in cable there. Maybe that wire is in a cable somewhere and we're going to find out. Here's the main speaker. Here is what I'm calling red, or the talk wire. This carries audio signals into the intercom from speakers that people are talking into, that is, speakers being used as microphones. And that comes out and goes to red on all of the stations that have switches. That is, all the stations except the door station. The black wire, chassis ground, not circuit ground. I'll bet it's actually circuit ground and they made a mistake, and same there, but I'm not positive. Okay. In fact, I'm sure that has to be circuit ground, and that has to be circuit ground. It just wouldn't work. We found and that too, I don't quite know what they're doing. It looks like they're mixing them up freely. I think the diagram drawer made a mistake. Anyway, some type of ground, one or the other. Then the switches only control whether the outgoing audio going to the speakers is fed to each station or not. So the white wire of each station goes through one of these switches. In the station, the white wire is for listening, that is, for sending sound into the station, and the red wire is for talking, that is, for sending sound from the station back to the intercom. You have a 50 ohm volume control, and you have a speaker which I would be willing to bet is a 45 ohm speaker rather than the usual 8 ohm speaker. And here's the talk listen switch on the main unit. The door speaker is a little different. It's wired from this and black only because it has no switch in it. So when the door speaker is on and the main unit is in listen, it's listening to the door. The person at the door does not have to flip a switch to be able to talk. So those are some of the main features of this intercom. As I was mentioning, I think the symbols for circuit ground and chassis ground maybe they're not mixed up. Maybe the speakers really are all returned to chassis ground, as is this transformer. The transformer is what fixes that. And phono input is returned to chassis ground. And that might or might not work very well. We'll see. Speakers are returned to ground because the output transformer on the speaker side is returned to chassis ground. Okay, all of these shenanigans because it would have been too expensive to use a power transformer and have circuit ground be completely isolated from everything else back in 1960. So there's the circuit, and next we'll look at the intercom itself and see if it works and what we need to do to get it in good condition to use. And here is the intercom on my cluttered workbench, which has needed
a good cleaning up for about 30 years. And here it is. It survived the journey to my shop. It looks dirty. What looks like dust on it is actually apparently spray paint from when some painting was done near it at some point during its long history. And I'm going to see if I can clean some of that off later. But first, let's look at what we have. It connects through this large multi-pin connector to the other units. So fortunately, the people who own it didn't have to undo dozens of little screw terminals and try to remember which wire went to which. It receives power from a built-in outlet, and to my great delight, this is a polarized plug. So it does distinguish between live and neutral, and that makes it much less of an electric shock hazard. If we turn it around, we see something relating to the antenna, maybe. This must be an antenna connection. The tuning capacitor, tubes, the electrolytic filter capacitor, which is certainly going to be replaced. This is an audio impedance transformer of some sort. More tubes, lots of switches. Now, I'm going to do something that I would not normally advise people to do with tube electronic equipment that hasn't been used in a long time. But I know that this one has been powered up within the previous couple of years, and nothing really untoward happened to it. I also know it doesn't have a power transformer, so we don't risk burning out a big expensive transformer if there's a bad filter capacitor. We do risk damaging the rectifier tube, but that's not so hard to replace. It's going to need lots of contact cleaning. It's going to need capacitors replaced. But first, let's see if it works and see if there's anything wrong with it. I'm going to have to try to figure out how to use this thing. I said I was going to tighten the tube sockets. What in the world is that? Well, it's something I learned from a YouTube channel called Fazio Electric, F-A-Z-I-O. And the idea is, if you look in a tube socket, every hole has metal surrounded by plastic, and the metal tends to splay out and loosen over the years. This tool is a sewing needle embedded in the end of a piece of wood, so I can use that as a handle. What I'm going to do is just insert it gently between the metal and the plastic toward the exterior of each of these holes so that it will bend the metal just a little and make it tighter again. So is it working better now? I think it is. I've plugged it in through my protected power supply and turned it on, and there's no noise in these switches anymore. The talk listen switch, there's no noise. Intercom volume, no noise at all. It's set to radio, intercom radio, intercom and phono. There's a lot of hum, but I have found out from the owner of the intercom that this wire, this yellow wire coming out of it is indeed connected to a radio antenna, so I've connected it to a shelf support that will work crudely as an antenna here. Let's tune the AM radio and see if anything comes in. Well, a moment ago, there was radio reception, and it's gone out again. So we have a radio-related problem. But first, let's deal with this hum and also change some parts that need to be changed for safety reasons. Another day of work on the intercom, and now I have it supported by clamps upside down so that I can work under the chassis. And high above my workbench, I have added a place to mount the camcorder so that you can see what I'm doing. Okay, time to replace capacitors. The first ones I'm going to go for are these two big ones, which have to withstand AC line voltage and are going to get replaced by modern line-rated capacitors. Now, an interesting thing about the design of this intercom is the circuit ground is actually a bus bar. That is, this metal bar to which things are soldered. And we've replaced two capacitors, putting line-rated ones where they belong. The rest of the story about the AM radio section is that the defect is apparently in the 12BE6 converter tube, for which I don't have a replacement, but the owner actually doesn't want to use AM radio. So to deactivate the AM radio and slightly increase the life of the other tubes, I've taken the 12BE6 out of its socket, and in place of its heater, its filament, I've connected three 330 ohm resistors in parallel here. Those are what I had lying around that would make roughly the right resistance. They have a slightly higher resistance, so everything will be a little less powerful, a little cooler, as if the line voltage were a bit lower. And because they have a fixed resistance and are not particularly low resistance when first turned on, they will protect the other tubes from the input surge. And to restore AM radio, the next owner or whoever wants to fix it will be told to clip out this trio of resistors. You can get a better look at it there, maybe. It is 3. And put a 12BE6 in the socket and then troubleshoot the AM radio, because there may be other things wrong. Now, the old intercom needed one more thing. You may remember that the circuit diagram showed a power-on light, a number 47 lamp, wired across the heater tap of the 35W4. Well, that's just not there. It doesn't exist in this model. I think that is another feature that's found only in a different model of this same intercom. So I have added one. People in the kitchen at the master unit are going to need to know when the intercom is turned on. So right here is a little neon indicator, very modern, very much later than 1960, but it does the job and it's inconspicuous. And when I turn the intercom on, it lights up. This is what it looks like. It has heavy heat shrink tubing protecting it where it goes through the chassis using the hole that was left from removing the big filter capacitor can. So here's the incoming connection from the neon lamp. It's two red wires twisted together, wired to the incoming power line at the power switch and the bus bar, and placed relatively far away from sensitive low-level circuitry, because neon lamps can be a source of electrical noise. For the same reason, the wires are twisted together. If we reactivate the AM radio, we may find we have a noise problem, but I think for now it's going to be all right. And the last test on my increasingly cluttered workbench, I've connected an 8-ohm speaker to a lot of speaker wire and then alligator clips so that I can connect it to the intercom as if it were a remote station either on talk or on listen, and I'm going to verify that both of those work with this in another room. By the way, these speakers are 8 ohms in this intercom. Other intercoms that I've encountered from the same era, Miami Carry intercoms, have 45 ohm speakers, but not this one. So it's done all with 8 ohm speakers that are easy to replace in this modern age. So let's see how it works. And as you can see, we can actually hear someone at the other station when it is wired as if its talk switch were depressed. Melody, are you there?
Yes, I'm here. How are you, everyone?
Greetings to the video audience from downstairs. And it also works the other way around when that speaker is wired as if it were in listen mode. So that's the great intercom repair. And for the really final step of the great intercom repair, I used paint remover and a razor blade scraper to take off some, not quite all, of the excess white paint and other paint that had gotten sprayed or splattered onto the intercom master unit somehow. So that finally completes the project, and now they're able to use it, and it doesn't even look too abnormal.